Thank you all for coming to the presentation today. For those of you who don't know me, my name is Dustin Harrell. I am a research agronomist at the Rice Research Station in Crowley, Louisiana. I also serve as the rice specialist for the state of Louisiana. Speaking with me today is also Mr. Cullen Minter. He works for Koch Agronomic Services, and he's going to talk a little about enhanced efficiency fertilizers and their role they can play in furrow irrigated rice. One thing, if you are a CCA and you need your CCA credits or CCAG, we do have the sign-up sheet in the back. And I don't know if any of you have the CCA app. It's pretty cool. You can open that app, and we actually have a barcode in the back. You can scan that barcode. You don't even have to sign up. You'll get your credits automatically. Looking at the room today, we do have next door, we have another furrow irrigated rice talk going on at the same time. So I was kind of curious what kind of crowd we would get today. And looking at the crowd with the full room, it looks like there's a lot of interest in furrow irrigated rice. And that's one of the reasons why I want to talk about that today, because truth be known, furrow irrigated rice is new. We don't know a lot about furrow irrigated rice and how to manage it. Right now, a lot of our recommendations are based on what we think, based on the science, is how we should manage it. What we lack is a lot of research backing what we think is going on, or it may be something different. So that's why we want to talk about furrow irrigated rice today. And mine specifically, we're going to talk about evaluation of nitrogen management in furrow irrigated rice. Just a little bit about furrow irrigated rice. Most of you know what furrow irrigated rice is. Furrow irrigated rice is where we're going to pull beds or actually dig furrows using a hipper roller like you see in the picture, and then we're going to furrow irrigate that rice, basically in upland conditions, similar to what we do with corn and soybeans. Each year in the state of Louisiana, I actually conduct a survey where we look at the different amounts of rice, the rice varieties that we plant, and how we manage that rice, and also how we manage the water in that rice. Here you can see back in 2017 was the first time that we actually saw any recordable furrow irrigated rice in the state of Louisiana. And our survey said we had about 2,500 acres of furrow irrigated rice. Just 1 year later in 2018, the number of furrow irrigated rice acres in the state of Louisiana doubled. And then last year in 2019, we actually tripled our furrow irrigated rice acres in the state of Louisiana to above 15,000 acres. Or about a little bit below 4% of our total rice that we plant in the state is grown in furrow irrigated rice. Now, risk management has told us that furrow irrigated rice, they are going to insure it with an additional part of crop insurance. And because all this rice before was grown when it was uninsured, we greatly expect that furrow irrigated rice in Louisiana and throughout the Mid-South is going to jump quite a bit in 2019. Also, since rice is penciling out a little bit better than some of our other crops, we'll probably see some people jump into rice next year, and they're probably going to want to try to do it with furrow irrigated rice. So it's becoming more and more popular. Why is it becoming more popular? Well, there's a lot of reasons why furrow irrigated rice looks favorable to a lot of our growers. And one of the biggest thing is we have less tractor passes across the field at the beginning and the end of the season because we're not pulling so many levees and tearing down those levees. So that alone is very desirable to our growers. Furrow irrigated rice gives us the opportunity to move more land in the rice that was not traditional rice land. Maybe we can pull in some land that has a little bit more slope than we would normally have on a flooded rice field. So that's pulling in a few more acres. It also allows the growers to make last minute or late decisions on what they're going to grow because we're growing it on similar beds. Early research has shown that if we use furrow irrigated rice instead of flooded rice, in some years we can see a water advantage. In some years that's been up to 40% in some of the research by others. If you talk to growers in the state of Louisiana, they're going to tell us that for the most part, most of our growers are happy with it, and they're seeing similar yields in their furrow irrigated rice that they are seeing in their flood irrigation rice. So that's why it looks desirable to a lot of our growers. Now, we do have a set of recommendations that we are telling our growers if they're wanting to move into furrow irrigated rice. And the first thing you have to know is about picularia or blast. Blast is one of the most devastating diseases that we have in rice production. And one of the reasons it's so devastating is it can pretty much wipe out a rice crop. Now, if you know anything about blast, you know that if you grow rice in upland conditions, it favors the development of blast. So we're putting it in an environment where this is really a severe problem and can be a problem. So what do? Well, if we're going to grow rice in furrow irrigated conditions, it's going to be important that we look at cultivar selection. And what we're going to look at is we're going to look at the blast susceptibility of a potential cultivar, whether that's an inbred cultivar or a hybrid. And we want to stay away from a cultivar if it measures out very susceptible or susceptible to blast. We want to stay away from those particular cultivars. We want to grow rice that is resistant to blast. That means most of our hybrids are resistant to blast, so they fit in favorably for furrow irrigated rice. But we can also grow our conventional lines too, especially if they're going to measure moderately susceptible or moderately resistant for blast. But I would say that what we're going to do at the beginning of the year is, if you're going to grow it with a variety that is a little bit less resistant, go ahead and pencil in 2 fungicide applications. You may not need that first one, but stay on top of it and pencil it in so you know that's going to be in the grower's budget if you're going to grow a moderately susceptible variety. This is a table that we take out of our rice varieties and management tips from 2020. And basically what I was going to show you is, if we take out all those very susceptible or moderately susceptible varieties, it really cuts down on the varieties we're going to select, at least in Louisiana, for growing row rice. Other concerns that we need to make sure our growers know, that the weed spectrum is going to change because we're not growing rice in flooded conditions anymore. Most of us know that the flood is type of weed control in our flooded rice. I would say that it's very important to keep that rice clean early on. One way we can do that is we can overlap residual herbicides. A lot of times this means we're probably going to have one additional herbicide, not all the time. But in some years we're going to have an additional herbicide application, so you may want to pencil that in. And also consider using a clear field system. Clear field system will give you one additional residual herbicide that you can use in your toolbox to keep that canopy clean until that canopy closes up. And it's going to close up a little bit slower in furrow irrigated rice than what you're going to see in flooded rice. And that's one of the things we need to think about. Now, we do have some general, and I have recommendations in quotes, because most of our recommendations when we talk about that are in our rice varieties and management tips publications are official recommendations backed on research. Well, the state of Louisiana, we don't have research on growing rice and furrow irrigated rice, but we know how nitrogen will act whenever we're going from a wet condition to a dry condition to a wet condition to a dry condition. We know that we have a little bit more nitrogen loss. We're going to have that because we're going from a flooded or a saturated to an unsaturated condition. And so with that in mind, these are kind of the general recommendations that we've been telling our growers if you're going to grow furrow irrigated rice. Now, every furrow irrigated rice field is not the same. There are a lot of different types of furrow irrigated rice, and don't think every field is the same. There are those that have, and I'm going to say that's about 5% of what we have in the state of Louisiana is what I call true furrow irrigated rice. And this is where we're irrigating down the furrows and we're not catching that water with the levee at the end of the field. It's draining out each time and we're not flooding that field. In these types of field, we're telling our growers that to maximize the efficiency of our nitrogen, instead of doing what we call a single pre-flood in our flooded rice, we're going to split that up into 3 separate spoon feeding applications. We tell our growers that yes, you'll probably expect to apply an additional 100 pounds of urea going in that system, and that just makes up for the inefficiency of nitrogen when you're going from a saturated to an unsaturated and back and forth. We also tell our growers to be sure that you want that application to go out on dry soil, and you want that irrigation to be slow. If it's a wet soil and a fast irrigation, you can move some of that nitrogen down the furrows and cause some problems there. And theoretically, upland crop strategies with nitrogen would theoretically work with our furrow irrigated rice as well. But I would say 95% of the furrow irrigated rice in the state of Louisiana is a hybrid between our flooded rice and what we call traditional furrow irrigated rice. This is where we're growing rice on traditional rice ground. It's nearly level. And we're going to have if we don't have a levee at the end of the field, we're going to go ahead and put it. If it's a field edge and a natural levee, we're going to start collecting that water as the season goes on. As that rice gets a little height, we'll increase the level of that water at the bottom of the field, and that water level is going to creep up into the field. By the time you get to mid and late season, we'll probably have more flooded rice than what we call furrow irrigated rice. And that's going to give us two zones. It's going to give us our upland zone, and it's going to give our flooded zone. If it's a really big field, you might consider three different zones. Kind of a hybrid in the middle with the flooded at the bottom and aerobic at the top. This makes nitrogen management hard because, truth be known, if we're flooding at the bottom of the field, this is simply our normal rice recommendations for flooded rice are going to work at the bottom of the field, but we're going to have different management at the top. A lot of times it's hard to split that nitrogen management, so we're still going to, in most cases, spoon feed that nitrogen out there. So because we do not have research-based recommendations for furrow irrigated rice, and because there's such a hot way to grow rice now, we did start research with furrow irrigated rice at the Rice Research Station in Crowley 2 years ago. And the justification for that research was that there was little research to validate best management practices for nitrogen in furrow irrigated rice. So that was our justification, and with that we had three main objectives that we wanted to address with our research. The first objective is we wanted to determine if the optimum nitrogen rate in furrow irrigated rice was the same optimum nitrogen rate in our flooded rice fields. Number two, we wanted to evaluate if splitting our nitrogen applications did improve our nitrogen use efficiency in furrow irrigated rice. How did splitting applications look like as compared to a single application, two split applications, three split applications, or four split applications? How did it look, and did we improve our efficiency when we did that? Our third objective in our research was to evaluate enhanced efficiency fertilizers, and I'm not going to talk about that in my presentation, but you'll hear a little bit about the role of enhanced efficiency fertilizers in furrow irrigated rice in the next presentation. So here's how we broke down the suite of trials that we did for the past 2 years. I broke them down into our nitrogen rate trials and our time of application trials. In our nitrogen rate trials, we looked at both a Rice Tech hybrid, CLXL 745, and a Clearfield long grain, CL 153. We looked at nitrogen rates ranging from 0 to 210 pounds per acre, and because we were doing, this is the beginning of our research, we only used a single pre-flood application or a single nitrogen application in our comparison, even though we know that that's probably not the best method for furrow irrigated rice. We used untreated urea, and we looked at these varieties, as I said, in both the flooded situation and furrow irrigated rice situation to compare those. Our time of application studies were a little bit different. We had two different nitrogen rates that we looked at. We looked at 138 pounds of N per acre, and we also looked at 184 pounds of N per acre. And these total nitrogen application was either applied at one time, two times, split three times, or split four times for an application. So here's the first results from our trial. This is from a trial in 2018. This is looking at the Rice Tech hybrid CLXL 745. This is a typical response curve. As we increase in nitrogen, we're increasing our yield. You could tell from this, if we were to calculate an optimum nitrogen rate, basically where can we achieve 95% of our relative max yield. For our furrow irrigated rice, we saw that that was going to be somewhere between 150 and 180 pounds per acre if we were to calculate it. If we looked at the data from our flooded rice and did the same calculation for the same hybrid, we saw that in 2018 the optimum N rate was actually approximately 50 pounds lower. So that equates to about a 50 to 46 pounds of N difference between the two systems, and that kind of validated that yes, in a lot of cases we do need about 100 pounds more of urea in furrow irrigated rice than we do in flooded rice. But that's what we saw in 2018. In 2019, we came back and did the same type of trials, and here you can see the response curves of both the furrow irrigated rice in blue and the flooded rice in red. And you can see that the shape of those nitrogen response curves are very similar. If we were to calculate the optimum rate, or 95% of our relative max yield, you can see that both for our furrow irrigated rice and our flooded rice, it both calculated out to 120 pounds of N per acre because the response curves were very similar in shape. However, what you are seeing is a lot different than our yield potential when we applied our nitrogen this way, and that was a single pre-flood. You can see that the yield potential was quite different between the two systems, and basically an indicator saying that a single application is not the way we need to go to maximize our yield potential in furrow irrigated rice. Here's the same response curve. This was for our CL 153. Again, this time the response curves are a little bit different, but still only 15 pounds of N difference from the recommendation from the two. The big takeaway is we're losing a lot of our yield potential when we're applying it in a single application like this. But if we were to go by science and just calculating our optimum nitrogen rate from the two, they would actually come out very similar. So here we can see the first of our time of application studies. This is for CL 153, conducted at the Rice Research Station. Again, this is actually on a Crowley silt loam soil. In orange, this is our 138 pounds N rate. The blue represents our 184 pound N rate. Here you can see the first one represents a single application, 2 applications, 3 splits, 4 splits in each of these. Here you can see that the 3 split application in 2018 was favorable over the other split applications, and it was both at both N rates. We saw that this was the optimum application method. So we found in 2018, and this is both for the Rice Tech Hybrid CLXL 745 and CL 153, this 3 split applications were the way to go with furrow irrigated rice. However, 2019, if you remember anything about last year in 2019, it was very wet. And when it was very wet, this actually changed our response this time. This time we saw that the 2-way split applications was good enough in both of our N rates, and we really didn't get an advantage of splitting it more than 2 times in furrow irrigated rice. So it just varies on year on which method was best. And this occurred both in the 745 as well as the CL 153. So in conclusion, our research is very early on in furrow irrigated rice. We're still learning a lot. We have a lot more to learn. Basically what we saw from our rate trials is that in 2018, the first year we looked at it, we saw that furrow irrigated rice, if we're using a single nitrogen application, needed about 100 pounds more urea than our flooded rice. And this was both for the hybrid as well as conventional variety. In 2019, we saw something a little bit different. If we went by just calculating an optimum N rate from a response curve, we found that the optimum rate was the same in furrow irrigated rice as well as our flooded rice. However, the yield potential was much lower if we went with that single nitrogen application, which is very important. That indicates that we are going to have to split our nitrogen applications on this furrow irrigated rice. Our time of application trials, we saw that the 3-way split was superior in 2018. 2019, when we were a little bit wetter, we saw that the 2-way split was just as good as the 3-way split, but we did saw in all cases that splitting was superior than a single application. Obviously, we need to do more research to support official best management practices in the state of Louisiana. We're going to continue to do that. I do believe that enhanced efficiency fertilizers can help stabilize some of this nitrogen as we go from wet to dry and with that, this is my contact information. If you have any questions or want to contact me at any time, please feel free to do so. I also put out during the growing season Louisiana rice notes or field notes. If you'd like to be on that, just give me an email and I'll get you put on that. But without further ado, I'm going to turn it over Oh, yes.
Quick question.
Sure, absolutely.
So on your split app research, do you think there was some element around timing that led to the different results of 3 applications in 2018 and 2 applications in 2019, or growth something like that, where it's like maybe the nitrogen demand?
Yeah, so there's a lot of environmental things that can affect the timing and when you're applying those from one year to the next. Soil moisture is a big one. As you know, if I was targeting 7 days apart between my split applications, if we're applying that second application on a wet soil or damp soil, obviously we want to have a urease inhibitor on that to reduce ammonia volatilization because it's going to speed that up. But that would cause a 3-way split because you're going to lose some potentially to look more favorable. If that soil had been dry, say on the second application, and then you irrigated it in, it got incorporated into the soil, well, the two applications would obviously seem superior because it was more protected in the soil. So a lot of things in the environment can alter what's good or bad. Soil type and just any conditions at the time of application can have a major effect. So we're definitely going to have to keep looking at this and as we move forward.
Hey, Dr. Harrell.
Yes, sir.
On your 3-way split, are you recommending front loading on the first shot, or are you saying go even all 3 applications?
Yeah, so let's talk about rice, okay, and the nitrogen uptake in rice. When the rice is small, like our typical 5-leaf rice, right before we begin to tiller, we front load in flooded rice because the water is going to incorporate that ammonium, it's going to go anaerobic, and it's going to stay available the whole season, so it doesn't matter how small the root system is, it can take it up at its leisure. If we're doing split applications and we're not flooding that field and not stabilizing that nitrogen, then if we apply a front-end loading it, we're actually going to have the potential for more loss because the root system's small, it's not taking up as much. As that rice gets bigger, it can take it up, bigger root system takes it up a lot faster. So in my research, I did it evenly, but my thoughts would be you'd probably want a little bit smaller on the first one and start getting a little bit bigger, or just make it easy and do 100 pounds of urea each application. But any more questions?
Has there been any research on ratoon cropping?
Yeah, so if you look at the state of Louisiana, all of our research, all of the furrow irrigated rice is in central and northeast Louisiana, well above where we do any ratooning. But I did look at ratoon at South Louisiana, even though we're not doing any furrow irrigated rice, and it was pretty interesting what we saw. We only did it last year for the first time, and what we did is we took our nitrogen rate study where we had the 6 different pre-flood nitrogen timings or single applications, and even though we didn't see an increase in yield with some of our higher nitrogen rates over, say, that 120 to 150 pound per acre rate, we did see significant increases in our ratoon production going into that second crop. So that was kind of interesting. But truth be told, there's not going to be a lot of furrow irrigated rice in South Louisiana because we don't have polypipe that can go over, some of our larger levees, which are common in Southwest Louisiana for crawfish production, because that's a burrow for crawfish production. So until we start using polypipe and polypipe in Southwest Louisiana, we're probably not going to see any furrow irrigated rice. We had another question. Yes, ma'am.
Dustin, in your multiple split application, did you split the fertilizer on the aerobic part of the field or the entire field? You said there were 2 zones of water.
Okay, yeah, that's a good question, and I'm sorry I didn't validate that. So we talk about in commercial fields there are going to be 2 separate zones, the flooded zone and an aerobic zone. In my research, it was only the aerobic zone. I did not hold any water because that's where we know the differences are going to be. So that's where we want to focus our research. So none of the water was held and in this research, just to emulate that top part of the paddy. Very good. With that, I'm going to